Hey guys, welcome to my 5th video on the molecules and matter topic. Today we are going to be looking at the specific latent heat. So the specific latent heat is the energy required to change a substance's state. So you have the specific heat capacity, which goes up to where it needs to change state, raising the temperature, and the specific latent heat is what is needed to change its state so it can carry on heating up and maybe change state again. So there are two types of specific latent heat. There's specific latent heat of fusion and specific latent heat of vaporization. Now the fusion is for solids turning into liquids or liquids turning into a solid, and vaporization is for liquids turning into a gas or a gas turning into a liquid. Now in a substance, such as water, while the specific heat capacity is similar, the specific latent heat is not the same at all, and it is different. So the specific latent heat of fusion of ice or water is different to the specific latent heat of vaporization in water or water vapor. So to work out the specific latent heat, we can rearrange the equation that we use to find the total energy of the transfer, and we can rearrange it. So this rearranges it. Imagine it as a triangle, almost. You've got divides and times here. You have energy at the top, mass here, and the latent heat there. See? So at the minute we've got mass times latent heat is the energy, but we can rearrange this so that the energy over the mass is the latent heat. Now to find the mass you simply weigh the object that you're doing. Simple. But to find the energy transferred, it's a little bit more complex. First of all, you'll need to, in your circuit, you'll need to put in an ammeter and a voltmeter so you can measure the potential difference and the current. Then you times the two together, so the voltage times the current, which will give you the power rating, which is in watts. Now, an alternative unit for watts is joules per second. So to get the total energy transferred, which is in joules, you need to times the power rating that you have by the amount of time. So, and then the energy is the power times the time. And that is how you get the total energy. So you get the total energy, then divide it by the mass, and you've got the specific latent heat. So that's how you measure the specific latent heat and how you calculate the specific latent heat. That is all for today's video. I hope it was of great help, and I'm going to be doing my last one in a bit, so stay posted.